Next we'll have to go to the step module and then the interactions. So module, step, step manager, and create. So alright, so I'm going to create a static general step. Continue. Nonlinear geometric effects for all manufacturing processes, it will be on. Anytime you are doing large deformation analysis, this has to be on. Time period. Now it doesn't really matter whether we do this simulation in 1 second or 10 seconds or 100 seconds, because material behavior is strain rate independent. There are no thermal effects, there are no inertial effects. So there is no real time scale, relevant time scale within this problem. So fine, we can arbitrarily set the time period to be 1 second. Next, go to the incrementation. We'll take the maximum number of increments to be 1000. The initial increment size, I'll take it to be 1 millisecond. Minimum is whatever is default, maximum is 1. So this is minimum is 10 power minus 5 seconds. Okay. Dismiss. Now output, field output requests, well, right now for implicit static general analysis, results are stored at every iteration. So that's fine. Okay. Alright, so this completes the step module. It's very straightforward in this particular case. Next, let's go to the interaction module. So over here we just need to prescribe the friction between the die and the blank and the punch. So for that, first we create an interaction property. For that, go to interaction property manager, create interaction property 1. It's a contact property. Continue. Mechanical. Normal is default. We don't do anything with normal. For tangential, we are assuming penalty formulation, and friction coefficient is 0.15. Okay. Now let's assign this interaction property. Go to interaction manager, create surface to surface contact. So first I'll create die blank interaction. Continue. So first select the master surface. Whenever you have a rigid body and a deformable body, the rigid body will be the master surface, will have the master surface. So I select the die, done. Now analytical rigid surface has two sides, the brown side and the purple side. So it's asking us, okay, which surface is going to take part in the interaction. So it's the brown side. So I select brown. Next I have to select the slave surface. Now before I do that, within the assembly actually selecting the slave surface is difficult. So what I'm going to do is I'm going to isolate this instance. So for that I go to replace selected. There's a problem. Replace selected instances. I select the blank, say done. Okay, so now I can see only the blank within the assembly. So I would like to see the bottom side because that's what is going to interact with the die. Okay, now I say surface and I select the entire bottom surface. Okay, say done. Okay, so this is the interaction property for the die and the blank. Okay, now we have selected the surfaces. It's going to be a surface to surface interaction. There will be finite sliding. We are using two configurations, path based contact tracking. We don't need to change any of this. I'm just going to select this option of adjust only to remove overclosure. So in case there are some small gaps between the surfaces because of some discretization errors or something, that will be removed because of this. Interaction property we have created only one, so that will be selected. I say okay. Alright, so die and blank interaction has been created. Next, create punch and blank interaction. So for that I go to create. I'll call this as punch blank surface to surface. Continue. So again I select the punch for the master surface. Done. Again, it's the brown surface which interacts, so I say brown. Next I have to select the slave surface, so for that I select again I have to select the part, so I go to this, I select the blank. Done. Now it is the top surface which is going to come into contact, so I select surface and I select the top surface of the blank. Done. Okay, once again the only thing I change is this adjust only to remove overclosure. Other options are all default. Say okay. That's it. Dismiss.